Good morning all. Today we'll discuss about transport layer protocols. So first of all, we should know what is a transport layer. Okay. So already we have discussed the same in OSI model, as well as we also discussed in TCP/IP protocol suite. So as you can see from the slides that transport layer is the fourth layer from the top in OSI model. So what is the main purpose of using transport layer is it is going to provide communication services to the application processes that was running on different hosts. You will be having different hosts. So it is going to provide the communication between the application processes. Okay, in the operating system you have processes, right? The communication occurs between the processes that lying on different hosts. Okay, so transport layer provides the services to the session layer. So you could understand that the transport layer lies above the network layer, and above the transport layer we have the session layer. So it is going to provide the services to the session layer and receive the services from the network layer. So that you could imagine where it lies. And the services provided by the transport layer including, like, we have error correction, we have segmenting, desegmenting the data before and after it's sent on the network. And the transport layer also provides the flow control functionality, and it is going to ensure that whether the data is delivered across the network in the right sequence. So the main duty of transport layer is to provide process to process communication. Okay. So next, comes the services that are offered by the transport layer. You could see, like, process to process communication, multiplexing, demultiplexing, flow control, data integrity, and congestion avoidance. So what do you mean by process to process communication? As we already discussed, like, transport layer is responsible for delivery of messages to the appropriate process. So how it is going to identify the particular process? So you already know, like, for devices you have some kind of MAC addresses and all, and you know, like, logical addressing, that is nothing but your IP address. And you could understand that there is something called as port address to deliver the segmented data to the correct process among the multiple processes that are running on a particular host. You have a particular host, and in the particular host there will be multiple processes that are running, and in order to identify the particular port, right, you will be having a port number. So the data will be sent to the particular port number. So segmented data will be it will be delivering the data to the particular process. How it is going to identify the particular process among the multiple processes by means of the port number. So what is a port number? How it looks like? It is going to it is nothing but a 16-bit address in order to identify any client server program. Okay, and the port so the port address is nothing but a 16-bit address used to identify the particular identify the particular processes amongst the multiple processes. Okay, next comes the multiplexing and demultiplexing. So what do you mean by multiplexing? So it is going to provide the multiplexing service in order to improve the transmission efficiency in data communication, as well as demultiplexing, right? Demultiplexing is used to, so once you are multiplexing at the one end, demultiplexing occurs at the other end in order to acquire the collected data coming from different processes. So transport layer provides upward and downward multiplexing. Upward multiplexing means multiple transport layer connections utilizes the connection of the same network. Transport layer transmits those several transmissions bound for the same destination along the same path in the network. And downward multiplexing occurs the other end, means a transport layer connection utilizes the multiple connections. Okay, and this multiplexing allows the transport layer to split a network connection among several paths to improve the throughput in the network. So what are the different types of multiplexing we discussed? What do you mean by multiplexing? So you would have studied in your electronics some kind of subjects. So you will be having multiple signals. You will be sending multiple signals or multiple streams of information over a communication link at the same time in form of a single or complex link. And at the other end, those single complex link will be splitted into end outputs. So that is what multiplexing and demultiplexing are otherwise called as smuxing. Okay. And there are two types of multiplexing are upward and downward multiplexing. And flow control, third comes the flow control. Flow control, why we go for flow control is it is going to ensure that the data is transmitted at a proper rate, at a rate that is acceptable for both the sender and the receiver. So sender is, suppose sender has the capability of for example, I'm telling you, like it is going to send 500 packets at a time. Okay, and the receiver is unable to receive 500 packets at a time, or it is going to receive 10 packets. Then there will be a flooding of those packets at a particular point that leads to congestion, right? So this flow control mechanism makes sure that the data is transmitted at a rate which is acceptable for both the sender and receiver by managing data. Okay, and the transport layer also provides a flow control service between the adjacent layers of the TCP/IP model as well. And since it uses the and it also how it manages now by using the sliding window protocol, by which the TCP model or the transport layer avoids congestion, or it provides flow control. By using the concept of sliding window protocol, it provides flow control. And data integrity in the sense for example, if I am sending some data, the data should whatever data, if I am sending hi, how are you, the same data should be received at the other end. Hi, how are you? I should not miss some like for example, I am sending hi in one packet, how in one other packet, r in another packet, u in another packet. If suppose r packet r packet is missing, and if you are receiving hi, how you, then you cannot achieve data integrity. So whenever the transport layer is used, so it also should provide data integrity by it can able to detect and discard corrupted packets, and it can also track lost and discarded packets, and it can able to retransmit them. And it also should recognize where duplicate packets occur, where the duplicate packets exist, and it can able to discard them, as well as buffering out of order packets until the missing packets arrive. Hi, how are you? It is sent through different paths, assume, and if it is receiving at the other end, hi is coming in one path and how is coming in another path and u is coming in another path, r got missed or r is retransmitted at after some time. So that the receiving end, it should wait until it receives all the 4 packets. Then only the entire message can able to be received. Okay. And then the congestion avoidance is congestion avoidance. So if load on the network is greater than the load capacity. Suppose assume your your load is for example, your brain capability can able to observe the class for 5 hours or 3 hours. Assume I am taking classes for 5 hours, 5.5 hours. What will be the load? The load on the network or the load upon the observing capability is particularly is less when compared to my even if I keep on giving lecture also, you cannot receiving it at the other end. That is the same concept lies here. In a network, if the load on a network is greater than the network load capacity, then the congestion may occur. As I said, like 500 packets, 10 packets, the same concept. So congestion control refers to the mechanisms and techniques to control the congestion and keep the load below the capacity. So but this particular layer can able to recognize overloaded nodes. So the nodes in the sense the host, and it can able to water flow in the tap, like we can able to regulate the water flow, right? The same way we can able to regulate the flow rate and take proper steps to overcome congestion avoidance and all. So we have three main protocols that exist for a transport layer. One is UDP, the second one is TCP, and the third one is SCTP. Okay, we already know about UDP and TCP, so I am not going to discuss much or talk in detail about UDP and TCP. So we'll further discuss about this SCTP. So UDP is a connectionless protocol, I think. So UDP is a connectionless protocol and it is unreliable one, because like the acknowledgement and all we can able to receive by using this TCP, whereas this is an unreliable protocol. You cannot rely on such cases. Okay, and UDP stands for, you already know that it stands for user datagram protocol, and it is one of the simplest transport layer protocol, and it provides non-sequenced data transmission functionality. That is why it is cost effective, and you can also say that we already discussed about in a real-time application where we can use UDP is like online games and all. We can go with UDP and it can have some tolerable delay and all, you can able to accept it. Okay, whereas in a mission critical applications or whenever a healthcare application, if you are designing, that case TCP is very important, whereas UDP you cannot use in that case. So UDP is considered as a connectionless transport layer protocol, and it is referred to be used when speed and size are more important than reliability and security. So whenever you want to send the data at a faster rate and size is very important, cost is very important, in that case you can go with UDP when compared to TCP. And whenever you are designing an application where security is important, reliability is important, that in that case you can go with TCP. Okay, then comes the TCP. So TCP is a connection oriented protocol. Excuse. TCP is a connection oriented protocol. It's a reliable protocol and it provides error and flow control. And TCP stands for Transmission Control Protocol. And we already know that it's a three-way handshaking. It uses three-way handshaking mechanism. It's a connection oriented protocol, and it is going to explicitly defines connection establishment, data transfer, and connection tear down phase to provide connection oriented service for the data transmission. I want to send a data means it is going to provide a connection establishment, then the data will be transferred, then an acknowledgement will be received, something like that. The process gets occurred. And TCP is the commonly used transport layer protocol. Like it provides like features of TCP, like what we can say is it's reliable, as we have discussed when comparing with a UDP. It's a reliable one, and it is secure, and it has a flow control, error control mechanism, and something. These are some of the features of TCP protocol. Excuse. And next comes the SCTP. So SCTP stands for Stream Control Transmission Protocol. So SCTP is one of the connection oriented transport layer protocols. It allows transmitting of data between sender and receiver in full duplex mode, and it is going to like integrate the features, like what are the advantages of TCP and some of the advantages of put together we have this SCTP. And so it is mostly designed for internet applications that have recently been introduced, and this is one of the new reliable message oriented transport layer protocol. As I said, like SCTP combines the best features of UDP and TCP. It preserves data loss and it preserves data loss by means of detecting the lost data, and it can able to preserve duplicate data. Duplication of data is avoided, out of data is avoided, congestion control, flow control. So many mechanisms that are there with TCP and UDP put together, we can able to achieve it by means of this SCTP. So this particular protocol has a transmission sequence number. So transmission sequence number, so whenever you are transmitting a data, there will be a sequence number. So data transfer in TCP you can able to control by numbering bytes. So each and every byte will be assembled or fragmented by means of sequencing number, so that at the other end, by using sequence number, it can able to arrange those bytes. So that is possible with SCTP, and each and every so each and every connection has a particular stream. So in TCP there is only one stream in each connection, whereas in SCTP there may be several streams in each association. So each stream can be identified by means of stream identifier. I think yes. And for the stream also, we have some set of sequence number. For same for a transmission, we also have a stream sequence number. Whenever a data is sent or when a data chunk arrives at the destination of the SCTP, so it is delivered to the appropriate stream, each stream, right? So after the transmission is split into streams, and it is delivered to the appropriate stream and in the proper order or not. In order to check that, we have the stream sequence number. So that is nothing but SSN. And packets. So packets, each segment carries data and control checks. So you are in transport layer data, we call data as a segment, right? And in a network layer we call it as a packet, and the data link layer we call it as a frame, right? So each and every layer has some kind of naming convention of data, right? In TCP, a segment carries data as well as control information. So we call a data as a segment in case of a transport layer. So data is carried as a set of or collection of bytes. Control information, we also have a control information appended with the data. Okay. So data is carried as data chunks, control information is carried as control chunks. So packet, so instead of a packet, actually we call data as a segment. Segment carries data and control information. That data is nothing but data chunk, and control information is called as control chunks. And why we go for flow control, we already have the same mechanism in TCP and all. So in order to avoid overwhelming the receiver, we have the flow control like what we have in TCP. And error control, in order to provide a reliable service, we have this error control. The like transmission sequence number and acknowledgement numbers, all these are used to identify some packets or some segments are missed and all. Okay, so by that way it can able to handle errors. And congestion control, here also like it can able to determine how many data chunks. So as I said, like the packets right here, like it is called as chunks. So it can able to determine how many data chunks can be injected into the network, so that it does not overwhelm the receiver. That is the problem what we have in congestion. Whenever we are increasing the data rate, in that case we have a congestion. In order to avoid that, we have a congestion control. So finally I can conclude that, so finally transport layer is nothing but the fourth layer of TCP IP or fourth layer of your OSI model or even in a TCP IP protocol suite, if I have a 5-layer model, in that case also we have the fourth layer. It is used to provide process to process communication. It provides data integrity, flow control, error control, congestion avoidance, congestion control, multiplexing, demultiplexing services and all. So and there are 3 important protocols where UDP is a provides connectionless service, and TCP and SCTP is a transport layer protocol which is going to provide connection oriented service. That's all about transport layer protocols. Thank you.